Hello, and welcome to the first lecture on cognition. The term cognition embraces mental activities such as thinking and representing information. It's a general term that refers to mental processes such as problem-solving, decision-making, memory, intelligence, language, and learning. It's your internal world and how you process your internal world. Now, thinking refers to the conscious manipulation of mental representations to draw inference and conclusions. So we're about to talk about mental representations. Now, our thoughts consist of mental representations of objects and events that we learn about in our environment. So when we're looking at cognition and thinking, we're not just looking at objects. We're looking at events as well. And it's easy to overlook that part of the puzzle. So, when we use mental images or mental representations of objects to process or to think about that information that is not physically present. So we're able to see in our mind's eye objects and manipulate those objects without having them physically in front of us, which is actually a very complicated thing to do, and yet we just do it naturally. Most researchers, when they're looking at representations, focus on visual representations, but other sensations can also be used when we're creating mental images. So like if I say the word flower, an image of a flower might come up, but for some of you, the idea of the smell of the flower, that might actually influence what type of flower you saw. Oops. Okay. So thoughts can take on the form of visual images. I'm a visual thinker, and if you're not a visual thinker, that's just not going to make sense to you. I always have like a film strip playing in my mind's eye. Anytime I read or speak or I'm thinking through things. So analogical representations have some characteristics of actual objects. Mental visual imagery, and I'll go through what all this means, involves the same underlying brain processes involved in seeing the external world, and symbolic knowledge affects the way we use visual imagery. On this lecture, we're looking a lot at visual imagery and how does the mind use and manipulate that information. So, first we have analogical representations. And these are mental representations that have some of the physical characteristics of an object, so such as a photo. Now, analogical representations are comparable to the object in certain respects, typically in a way that makes it clear the nature of the things compared. And I'll show you a slide in just a moment. So, thus, it's analogous to the object. I'm coming back, actually. So here we have an analogical representation of a violin, the actual picture of a violin. That is a representation that tells us about a violin. We don't have to explain a lot because people can see the object for themselves. Then we come to symbolic representations, which are abstract mental representations that don't correspond to the physical features of an object or idea. So with symbolic representations, we're not using visual imagery at all. So things like words and ideas are going to be symbolic representations. So the word violin is a symbolic representation. So if we want an analogous representation for a violin, we use a picture of it or an image. If we want a symbolic representation, we use the word violin. Now, research has found that we process mental images as if the object or event is physically before us. Now, this is really interesting to me. So something they've found with people who have schizophrenia or other disorders that cause hallucinations is that when the person is hallucinating, so let's say they're having a visual hallucination, their brain is activating as if what they're seeing is real, that the event that they're seeing right now, which for the rest of us isn't real, but in their mind, their brain is processing it as that hallucination is really happening in front of them. And, people will have auditory hallucinations as well. So for them, they'll just hear it. And the auditory system will activate if they're hearing a hallucination. It's really interesting that the brain cannot tell. When the brain's hallucinating, it can't tell the difference between what's real and what's the hallucination. It's all real for the brain. Okay, so when we visually scan objects, or an event, so scanning an event would be like, watching an event take place. So visually scanning an object or event takes just as long with mental images as it does with physically present objects or events. That's interesting, that the aspect of time doesn't change as our mind manipulates that information. Now, mental images allow us to mentally manipulate objects or events in a way that we could not manipulate physically present objects or events. So mental imagery gives us flexibility and creativity. In the mind's eye, we can do with objects what we cannot do if they're physically in front of us. So, when you scan a map, it takes a certain length of time. The further away an object is on the map, the more time it takes for your brain to scan it. If you have a mental map, so let's say you're trying to explain to somebody how to get from LCC to the Hull Center, you're using a map, mental representation of the map of how to travel to the Hull Center, and your mind has to scan that. And as you are scanning through that in your mind, it's just as if you were looking at a picture of the map, scanning through to get from LCC to the Hull Center. Let's see. I'll just let you look at this one in your textbook. Now, research has found that we process mental images as if the object or event is physically before us. Let's see. And as I've already mentioned, when we manipulate mental images, our brain activates as if we are really seeing that object. And we have great speed when mentally manipulating objects. The ability to manipulate mental representations really is quite an achievement. Most species don't have that. In order to learn how to use a tool, so, one of the big jumps for humans was the ability to use tools. In order to use a tool, you have to be able to manipulate an image, and apply it to a second image, and get those two mental images to work together. Hope that made sense. That's actually a very complicated process. It doesn't seem complicated because our mind just does it, but it's actually a very complicated process. So, with this graphic, I'm sure you can all tell it's the number 3. You were able to tell that very quickly, even though these 3s all need to be manipulated to be a proper 3. Okay, so that's the end of 8.1, and we'll keep going. Thank you.